All right, so today we are going to be talking about combination circuits, which are going to be resistors that are in a circuit that both consists of parallel, equal access to voltage, and series, the current doesn't have a choice, kinds of sets up. So, lots of things in real life deal with this combination circuit kind of idea. For instance, all of the lights around the room that I'm in are wired in parallel because they need that equal access to voltage. In this case, it's the 120 volts that comes out of the wall. However, each one of those lights wired in parallel is then wired in series, current doesn't have a choice, with a switch. That way, the switch, when you turn that on and off, then operates all the lights in the room. So here's an example of one of these combination circuits. I have a 6-volt power supply, in this case a battery, that's then hooked up to resistor D, which is 2 ohms, and then the current has a choice as to whether to go through resistor C, which is 6 ohms, or then resistor A followed by resistor B, which is 8 ohms and 4 ohms apiece. So we're going to need to do the analysis on this circuit and identify which parts are in series and which parts are in parallel. So what we're going to do is we're going to set up the same grid that we have been using in order to then do the analysis on this circuit. And doing this type of circuit analysis is what allows all of the electronics that we use on a daily basis to work. For example, the cell phone that is currently recording this little talk. So let's go ahead and do that. And the best way to get started with this is to start as far away from the battery as possible and work our way back towards the battery. And you will see that I was very careful in planning this out because we're going to also go in alphabetical order. So with that, let's draw our first chart. So we're going to put Ohm's law over the top, so that's going to be V equals I R. And we're going to draw our chart. And we're going to be dealing with resistor A and resistor B first. So this is going to be resistor A. This is going to be resistor B. And then this is going to be not total like what we have in the past. Total, we don't get the right total until we include the battery. And you're going to be really looking forward to writing down total because that means you are almost done. But resistor A and resistor B don't add up to the total this time. We're not all the way to the battery. Instead, what they're going to do is they're going to add up to resistor AB. Red plus blue equals purple. So this is going to be resistor AB. All right, so let's now fill in some of the knowns that we have. So we know that resistor A is 8 ohms, and we know that resistor B is 4 ohms, and that's all we know. We don't know anything more at this point, but we'll work on that. But we can now look at this and use some of our equations. For instance, adding resistors together in series, we know that RA plus RB is going to equal RAB. So we can then go and say that this is going to be 12 ohms. So what we've essentially done here is taken these two resistors and made it into a single resistor mathematically. So we've now found the equivalent resistance for resistor AB. Now, when we look at this, we know that the current doesn't have a choice. So that's a series circuit. And this is why I was able to add them like this. And it's a good practice to get into to write an S right here for series. That way we know what kind of chart we're dealing with. And then go ahead and circle I because the current's going to be the same everywhere in this chart. And the reason why we're going to do that is now resistor AB, that has equal access to voltage with resistor C, so those are going to be both in parallel. And now we can make a new chart that's going to have resistor AB in parallel with resistor C. So let's see what that looks like. So I'm going to make a new chart. And put Ohm's law over the top, so V equals IR. And down the left-hand side, I'm going to put the resistors that we're going to be dealing with. So we're going to be dealing with resistor AB. And that's going to be in parallel with resistor C. And all of that is going to combine to make resistor ABC. So we now have resistor AB in parallel with resistor C, and that's going to then add up to make resistor ABC. And this is going to be a parallel chart. So I'm going to make parallel lines right there to remind me when I go back and fill in all of my unknowns that this is going to be parallel. And because it's a parallel part of this circuit, I'm going to circle the voltage because that's going to indicate that the voltage is the same everywhere in this parallel part of the circuit. All right, so let's fill in our knowns here. So we know that resistor AB is 12, and resistor C is 6 ohms. And when I go through and add those up with the equations for resistors in parallel, that's 1 over RAB is going to equal 1 over R ABC, so that's the total for this, equals 1 over RAB plus 1 over RC. That's going to then be adding these in reciprocal, and we're going to end up with an answer for our ABC as being 4 ohms. So now we have resistor ABC as being 4 ohms. Now, let's go back and look at our circuit and see that we now have these all combined into find the resistance of all of this is one big block. So we have the effective resistance of resistor ABC, and that's going to be in series with resistor D. So all of this is going to be in series with resistor D because the current that goes through here then has to go into this block right there. So resistor D is now in series with essentially the resistor ABC. And I could redraw this as showing one resistor right here, but I would run out of board space. So with that in mind, let's go ahead and do that next chart where we're going to have resistor D in series with resistor ABC. All right, so we've got V equals I, R. And we have resistor ABC. We have resistor D. And this is going to be in series, so I'm going to put an S right there. And the series circuit means that the current's going to be the same, so I'm going to go ahead and circle I. And now I'm going to, hey look, I have all my resistors taken care of. Now I can finally write the word total. So I can now put total down here. And that's going to be real nice. So now let's fill in all the things that I know now. So resistor ABC, that's going to be 4. Resistor D, let's see, resistor D, that's going to be 2 ohms. And my total voltage, I now have that. This is now 6. So this is now 6 volts. I can now start filling in everything else. So this is in series, so I know how to add resistors in series. That's just adding, so 4 plus 2, that's going to be 6. And now I can start filling everything else in. So, using Ohm's law, I can find that the current is going to be 1 amp. And now that I know that that's 1 amp, I have this circled, so I can just go ahead and fill in 1 amp and 1 amp because I did the work ahead of time in circling and making life simpler. All right, and now what I can do is I can also fill in everything else. So our D, that's going to be 2 volts, and our ABC is going to be a total of 4 volts. Now, I have our ABC here, I have our ABC here, and I can copy this row over to here. So this is going to be 4, this is going to be 1, and now I can look and see, oh, this is a parallel circuit. I wrote that down. The voltage is going to be the same because I circled that. And now I can go, oh, this is 4, this is 4. And now I can go and figure out what my currents are going to be. So, let's see. 4 divided by 12. That's going to be 0.33 amps. And we can see 4 divided by 6. That's going to be 0.66 amps. As a check, we can look to make sure our currents add up. 0.33 plus 0.66 equals, as near as counts in horseshoes and hand grenades, 1 amp. Now, this was for resistor AB. Resistor AB also exists over here, so let's go ahead and copy that information over. So resistor AB, so this is 4 and 0.33. And I can look at this and go, hey look, this is a series circuit. I circled I, so the current's the same everywhere. So now I can go 0.33, 0.33, and now I can go and figure out what the voltage drops across those 2 resistors are. And now I'm going to have slightly less than ideal numbers, but for resistor B, that's going to then end up being 1.33 volts, 4 times 0.33. And now looking at this right here and doing some quick math in my head, for the voltage for resistor A is going to be 2.66 volts. And if I did everything right, this should add up to that. So 1.33 plus 2.66, yes, that equals 4 volts. So now what I've done is I now know the current and the voltage drop for each one of these resistors. And that will allow me to calculate the power that each one of these resistors is using. So you now have a problem set to start working on, which is going to be using this information with using these tables in order to analyze combination circuits, which have both series and parallel components. And one of the best things to do is double check to make sure that you really are adding resistors together properly. Parallel circuits have equal access to voltage. Series circuits means that the current doesn't have a choice as to which direction to go. And identifying which resistors is which is going to be the most challenging part of this section. With that, good luck, and I wish you the very best of days.